All right, everyone, here we go. Review number 5. The formula V equals I times R gives the voltage in volts as the product of the current I in amps and the resistance R in ohms. Don't worry about understanding all those electrical terms. We will be learning those your sophomore year in POE. But we're given this formula, and they just tell us to solve the formula for the current, which is I. In other words, get that I by itself. So this is going to be really simple. What would we do to both sides to get I by itself? We need to get rid of R. Since it's being multiplied times the I, we just need to divide both sides by R. And now the I is going to be by itself. I can just flip the formula over and put the I on the left instead of on the right, and just say that I equals V divided by R. And there we go. Solved for I. Number 2, parking garage charges $1 for the first half hour and 60 cents for each additional half hour or portion thereof. If you have only $6 in cash, how long can you park? So the first half hour, that means like the first 30 minutes, right? It's $1. So whether you park for 0 hour, like 0 minutes, that's probably 0. But if you pull into the parking garage, even if you immediately pull out, you still paid $1. And then up to the first half hour, it's just $1, right? Then for each additional half hour or portion thereof, it's 60 more cents. So a little bit past 0.5 and I go to 160. 1.5 would be another 60 cents, 220. Another 0.5 hours. So notice I'm saying half hours is just 0.5 because that's how they keep referring to these things. So that's why I'm going up 0.5 at a time. Add another 60, that's 280. 2.5 will be another 60, that's 340. I'm just going to kind of keep adding these things out because this won't take too long to get to $6. Okay. 3.5 is 460. 4 would be 520. 4.5 would be 580. And then 5 would be 640. So I've gone too far when I've reached 5 hours. So I believe the most we can have is 4.5 hours if we only have $6 in cash, right? Because that first half hour was $1, and then just as soon as I go a little past that first half hour, I got to pay 60 cents, and that's good up until the next half hour ends, which will be at 1 hour. So yeah, 4.5 hours is how long we can park. Because if we wait a little bit longer, we're immediately going to be paying $6.40. So 4.5 hours, that's as long as you can park. Number 3, the number of rooms rented at a hotel is related to the room rate by the function rule N of R equals 200 minus 2.5 R. What is the domain of the function in terms of the context? The domain of the function in context. So domain deals with the X numbers. But if this is a function, so they're not really going to always be given the X variable. So we can also think of it as the input variable, the input values. So the X values, the input values, those are the ones that are inside the parentheses and inside the formula. So that we're talking about R here. What are the R values that make sense? So think about it. R is the room rate. If I go back and I read through this, the number of rooms is related to the room rate. So N is the number of rooms, and R is the rate. So what are the room rates we can charge here? Well, let's go graph this function and see what it looks like, because I think that's going to be our easiest bet to come up with our answer. 200, let's write it in function notation actually. We'll say N of R equals 200 minus 2R. I'm going to zoom out, see what this looks like. Okay. I think it's obvious that positive numbers are the only thing that makes sense here, right? Because you can't have negative rooms and you can't charge negative dollars per room. So what are the R values that are positive? And when I say positive, let me rephrase that are non-negative. Like, so we can maybe think that 0 makes sense in some cases, but negative numbers don't. So what are the R values, which are like our X's, our inputs here, that make sense? Well, we could charge $0 a room, and then it looks like all 200 rooms are going to be filled because that's the output up here. Okay. If I look at this, charge R of 0, charge a rate of $0, and your N, your number of rooms that you rent out, is 200. So that's the smallest we can go. It's $0 per room. And then if I charge $100, then 0 rooms are rented out. If I go a little past 100, now it starts saying that I'm renting negative rooms, which doesn't make sense. So our domain that makes sense is going to be R values between 0 and 100. That's the domain that makes sense in terms of the context. So the rates can be from $0 up to $100. Okay. Those are the only ones that make sense. Number 4, which of the following function rules would best represent the number of dots for any given stage n? So when we have stage 1, we have 1 dot, then we have 3 dots, then we have 6 dots, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. Okay. So I'm just going to look and see if I can identify the pattern here and see if it's like a form that we've seen before. So we've got 1 to 3 is +2, 3 to 6 is +3. It's immediately changing the value. So this is not going to be linear. So it can't just be like f of n equals n. First off, like that's obvious because that would mean stage 2 has 2 dots, stage 3 has 3 dots, stage 4 has 4 dots. That's not the case. Yeah, because it's changing here. So would quadratic work? Well, if we do 1 squared, that's 1. That works for stage 1. 2 squared is 4, but we only had 3 dots. So no, this doesn't work. 1 squared plus 1. That would be 2, but stage 1 only had 1. So no, this one fails on stage 1. What if we do this one? N squared plus n divided by 2. So for stage 1, that would be 1 squared plus 1 divided by 2, which is 1 plus 1 is 2 divided by 2. That's 1. Okay, that works. So f of 1 equals 1. Stage 1 has 1 dot. That's right. Stage 2, 2 squared plus 2 divided by 2 would be 4 plus 2 divided by 2. That's 6 divided by 2. That's 3. So f of 2 would be 3. Stage 2 has 3 dots. That's right. And instead of me keeping plugging these in, let me go to Desmos and just type this function rule in and see if it matches. F of n equals, let me delete the other one. Let's try. We got to put all this on the top. N squared plus n divided by 2. Then I'm going to go to settings, hitting the little wrench, and hit table. And then just see, what about stage 3? What about stage 4? And look at these numbers we're getting. Stage 1 had 1, stage 2 had 3, stage 3 had 6, stage 4 had 10. That matches exactly what I see in the number of dots. So yep, D is going to be the correct answer. So showing you that Desmos will be able to take a function rule and turn it into a table, if you would like it to, by just hitting that settings button and then hitting the table button. Okay. So just wanted to point that out to you. Number 5, Bakery A charges $15 for the order and 75 cents per cupcake in the order. Bakery B charges $5 for the order and $1.25 per cupcake in the order. Write a function representing the difference in cost between Bakery A and B. This is another one we did in class, but a quick review of it. Bakery A, let's call that function A of X. It's $15 for the order, and then you're charging per cupcake. So that's a linear function. 15 for the order, 75 cents per cupcake. Bakery B, we'll call that B of X, is only $5 per order, but their cupcakes are more expensive for each one. So that's 125X. So write a function rule representing the difference. We'll call this difference function just F. That would be A minus B, which would be 15 minus 5 is 10. And 0.75 minus 1.25 is negative 0.50X. Again, if you were writing this out, like so, A of X minus B of X, you would need to put parentheses around that second part. And before you go simplify, make sure to change the signs of each part in parentheses or in that second parentheses, and then go back and combine the x or the like terms. 15 take away 5 is 10. 0.75x minus 0.125x gives us the negative 0.50x. So this will be the function rule or expression for the difference between bakery A and bakery B. If you have any questions on that review, just let me know.